This video covers the first section of chapter 11, which is about solids and cross sections. So in chapter 10, we were talking about area, and now here in chapter 11, we're primarily going to be talking about volume, which is the three-dimensional space that an object takes up. And so first, we just need to talk about these three-dimensional shapes before we can talk about how to find the volume of them. So some vocabulary. We have three parts of one of these shapes that we're going to be talking about. And in general, the shapes are called polyhedrons. So we have polygons, which are two-dimensional shapes, and then polyhedrons are three-dimensional shapes whose sides are just polygons. And each side of the polyhedron is just called a face. So this box here has 6 faces, right? Front, back, left, right, top, bottom. So we've got faces. We also have edges. An edge is just a part of the polyhedron where two faces come together. It's really a line or a segment. So this red line right here is an edge. We'd also have an edge here, an edge up here. There's a bunch of edges here. So those are edges, and then you also already know the word vertex. It's just a point where some of the edges come together. So here we got a vertex there, a vertex there, a vertex there, etc. Okay, so if we've got this polyhedron here, this is a pyramid. We're going to basically talk about all of the faces, all the vertices, and all the edges on this polyhedron. So on this pyramid, we have 5 faces. We've got this square, and then we've got 4 triangles. We've got a triangle here, a triangle back there, a triangle on the right, a triangle on the front. So here would be the different faces of the polyhedron. Triangle DEH, triangle EFH, triangle FGH, triangle GDH, and then that square on the bottom, the quadrilateral DEFG. The vertices, those are just the points. So that's going to be D, E, F, G, and H. And then the edges are basically the segments connecting those points. So we'd have one that's DE, EF, GF, etc. And there's actually 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. All right. So a guy named Euler, he realized as he was looking at these polyhedrons that there's a formula that if you know 2 of these 3 numbers, you can always figure out the third one. If you know the number of faces, number of vertices, and the edges, it always satisfies this formula. Faces plus vertices equals edges plus 2. So if you think back to what we just saw, we had 5 faces, 5 vertices, and 8 edges, which fits that formula, right? 5 plus 5 equals 8 plus 2. All right, so let's look at this box, and we're going to determine the missing piece of information. We've got 6 faces, 12 edges, but how many vertices are? So we're going to use that formula. F plus V equals E plus 2. So let's plug in what we know. We know everything but the number of vertices, and we're going to solve for V. So there are 8 vertices, which hopefully you can see. We can count them, right? 1, 2, 3, 4, 5, 6, 7, 8. 12 edges and 6 faces. This is useful because sometimes it's hard to keep track of which ones we've counted, and also sometimes these solids get really big, and so we can use this even if we can't count them all by hand. So we have 8 vertices on the solid. This next one, we've got 7 faces and 7 vertices. So how many edges will we have? Well, F plus V equals E plus 2. We plug in 7 for faces and for vertices. And we solve for E, and we get 12 edges. All right, and the last thing we're going to do is just talk a little bit about the different types of solids that we can have. So one of them is called a prism. So a prism is just a polyhedron with 2 congruent parallel faces called bases. So this would be a triangular prism. This is a rectangular prism, just kind of a box. And so all of the sides are going to be polygons. We have 2 congruent polygons, and then they're connected by rectangles like this. So that's a prism. We've also got a pyramid. So polyhedron in which one face called the base can be a polygon, and the other faces are triangles. So in this case, we have one base and then a bunch of triangles. So here, this is a square pyramid. The bottom's a square. All the rest of the sides are triangles. This would be a pentagonal pyramid. Base is a pentagon, and each of the sides are triangles. So we compare that to a prism where we've got 2 bases and the sides are rectangles. Here we've got one base and the sides are triangles for a pyramid. All right, a cylinder that involves a circle. It's a solid with two congruent parallel bases that are circles, and then they are connected all the way around the circle. And so this would not be a type of polyhedron because the circle is not a polygon. So a pyramid and a prism are both types of polyhedrons, but cylinder is not. Another type of solid that's not a polyhedron is a sphere. A sphere is just basically a ball, a set of all points in space equidistant from a given point called the center. So like the Earth is roughly a sphere, a baseball, a basketball, all those things that you probably already know that are roughly spheres. Three-dimensional circle, basically the way we want to think of it. It's also not a polyhedron because its sides are not polygons. There actually aren't any sides of a sphere. It's just smooth all the way around. And then the last one we're going to talk about is a cone. A cone has a circle for a base, and then all of the points meet together at a vertex up top. So that would be a cone. Again, not a type of polyhedron because a circle is not a type of polygon, and actually the side isn't a polygon either. So it's a solid that's not a polyhedron.